In this video, I'm going to give you some tips on how to solve some slightly more complicated exponential functions. It's really an example of stuff that we have already seen, but it comes up in the IXL, so let's give it a quick look-see. All right, so here are the two rules we know about exponentials, that the derivative with respect to x of e to the x is itself, and the derivative with respect to x of anything else raised to the x power, where a is any constant at all, is a to the x power times the natural logarithm of a. And so based on this, here is the kind of problem that you might get in IXL. They would want to know what is the derivative of e to the 5x power. All right, so to solve this, the first thing I'm going to do is I'm going to write this in a slightly different form. I'm just using my exponent rules. So this is e to the 5 power to the x power. So remember, when you're multiplying your exponents, you can express that as a power to a power. All right, so finding the derivative of this function is just an example of this second function where a is equal to e to the 5th power. All right, so the derivative of this is equal to the natural logarithm of e to the 5th power times e to the 5th to the x. Okay, and let's simplify this a little bit because there is room to simplify this. Let me bring my calculator so we can double check to make sure that this is true. That if I calculate e to the 5th power, it's that. And then if I take the natural logarithm, I get Shazam right back to 5, because natural logarithm and e to the x power are inverses of each other. And so e to the 5 to the x, I'll go back to writing that as e to the 5x. Okay, so what you can see here is that the derivative of this function is just 5 times e to the 5x. And you're going to find that this is true in general. We will talk about more general cases of this when we start talking about the chain rule. But what you can do if you've got e to some function of x is you can just write e to that function of x, and then the coefficient is going to be the derivative of what it is. All right, so for instance, if we had something like e to the x squared power, and it's not a power to a power, it's e to the x squared. The exponent of this is x squared. The derivative of that turns out to be e to the x squared times the derivative of x squared, which is 2x e to the x squared. All right, we'll talk about that in a lot more detail, but the one thing I wanted you to see going into the IXLs is when you've got something e to the a linear multiple of x, you're just going to bring that coefficient down as the coefficient. All right, so that's how you calculate things like e to the 5x power.